This lesson is about hot water heaters and laundries. The thing about hot water heaters is there's multiple different types. There's 4 to be exact that we're going to be talking about. Every house might have one or another, or sometimes different combinations. Being able to recognize them and how they work is important, so pay attention. The second area is laundry. Laundry has some safety issues, and certainly anywhere that you have electricity and water, you need to take special attention. So why don't we get on with it?
Now we're going to talk about hot water systems. There are many devices to create hot water in a home. Here we actually have a tank. So let's get started. One of the things that we want to understand is the manufacturer. So here we have a GE profile. So we're going to come to our checklist and we're going to identify GE profile. The next type is a tank. We're going to be discussing about the other systems, but for today we're going to be discussing about the tank. So, the energy source, this is electrical. So it's being powered through electricity. You may have propane, you may have natural gas, but this tank is being powered through electricity. The age. Now, one of our standard practices is we don't have to determine the exact age of a system at the time of the inspection, but we definitely want to understand it. So what we would do is we're going to look at the label. We're going to understand the serial number, so we're going to write that down. The model number, we have a GE profile. And then once we get home and write up the report, we're going to look up what the age of this system is. Now, after we determine the age of the system, we're going to understand the capacity. On this label, it's going to tell you everything. This is actually a 50-gallon tank. So we're going to mark down a 50-gallon tank. Now, we're going to look at how does the water come into the system itself. Now, we're not just looking to see where the valves are. We're going to be looking at each of the joints to see if there are any leaks, any corrosion, how it's actually entering the tank itself. And then this is the exit for the hot water. And again, we see the soldering. Now, we may not always like how the craftsmanship was performed, but if it's functioning correctly, then it's not a defect. All right. So I'm not seeing any leaks. I'm not seeing any issues, but I see a little bit of corrosion here along the needle valve here. But again, I'm not seeing any water leaks. Now, the next thing that we're going to look at is what is called the temperature pressure relief valve. The functionality of the temperature pressure relief valve is in the event if the temperature gets too hot and creates a high pressure situation, this relief valve will pop and then allow water to come out at the bottom. So over here we have an extension of the temperature pressure relief valve. That extension should be about 6 to 8 inches off the ground. Anything further than that, if we're at one time examining the system, and if that released, the possibility of hot water coming in contact with us is a high probability. So we do have an extension. So we're going to go back to our checklist, and we're going to identify that the safety relief valve was noted, the safety extension was noted, the supply valve was noted. Drain discharge. Now, you can see right here we have a drain discharge. The reason why we have a drain discharge is for 2 functions. 1, to drain the system if it has to get replaced, or 2, for periodic maintenance. You end up draining the system to remove any impurities and debris at the bottom of the tank, because that definitely increases the longevity of the system. The next item is we're going to be looking at the rust, or is there any rust? And as you can see, along the rim plate here, you can see rust, you can see corrosion, and then along the top you can see some rust and corrosion. Now, you may see that this break, and that's just because of the manufacturing of the galvanneal getting chipped away. But also, we have a sump pump in this area which creates a high humidity. So that can be another reason why we're seeing some rust on the system. But in any event, we're going to be looking at the age. We definitely see some rust. So one of the things we're going to recommend to our client is to begin budgeting for a possible new hot water tank. Now, the other item we have here is testing the hot water. When we've been going through the bathrooms, the kitchen, or any location that would have hot water, we're going to be testing it at that location to verify and validate the operation of the hot water tank. Sometimes, if the house is unoccupied, clients will actually put the water tank in a shutdown condition. So we may not have hot water. So we do not, during a time of inspection, to actually turn on that breaker. If something is in the shutdown condition, we don't touch it. We would ask the selling agent to turn on that breaker, and when we pick up our radon, or if we have to return in 48 hours or 24 hours, that's when we'll test the hot water system. All right? And then the last item we have here is the location, which is in the basement. That doesn't mean it's always in the basement. If we're on a slab, it'll be in a utility closet of some sort. So, reviewing the hot water tank, using the checklist, this is how you're not going to become negligent and miss any defects when it comes to a hot water system. And that's how you perform an electric hot water tank inspection. Now that I showed you how to perform an inspection on a hot water tank, being the source of electric, I'm going to show you how to perform an inspection where the fuel is natural gas for a hot water tank. So we're going to first walk around the system to look at the overall condition. Is there any rust along the rim? Is there any rust on the screws or possibly along the bottom of the system? Next, we're going to be looking at the gas line. As the gas line comes down, we're going to be looking at this drip leg. The drip leg needs to be at the very end on the vertical portion of the gas, because all the impurities, being water droplets or any dirt in the gas, are going to fall down at the bottom. You cannot have a gas line coming in horizontally with the drip leg here. It's not going to catch any of the impurities. We're going to take note that we have our gas valve here. It's going to come into the solenoid connection, which is going to provide the gas to heat up the tank itself. As we're sitting here, I'm going to take note of the label. This is a Bradford White system. We got 40 gallons. And sometimes people actually write when the system is installed. Here we're going to take note of the model number and the serial number. Go to the website, Bradford White. You can do it here at the inspection site or at home when you're writing up the report to identify the age. Consumer Reports has it about 10 to 12 years for the life expectancy of these systems. But we know if you have proper periodic maintenance of the system, draining the tank, such forth, these systems will last a lot longer. But again, we want to identify the age of the system, because if it is older, 15 years or 18 years, we're going to probably let our client know that, hey, you might want to start budgeting for a possible replacement in the future. Now, one of the safety items for a hot water tank is our temperature pressure relief valve. We have it over here. We have our pipe extension coming down. It's about a good distance, 6 to 8 inches off the ground. And the purpose of this is if the tank pressure gets too high, this is going to release the water, or if the temperature gets too high, it's going to release the water. And typically, I shouldn't say typically, this is a common defect that we see, is a missing extension pipe. Now, because this is natural gas, all right, based on the system, we have to remove the carbon monoxide. So that's why we have a fan here. So when this system's operating, the carbon monoxide is going to raise, the fan is going to turn on, and then it's going to discharge that carbon monoxide out here. So one of the things that you want to do is when you're performing an inspection of the hot water tank, you're going to take your CO detector, you're going to have an understanding of what the ambient condition is. And when you're inspecting the system, once again, you're going to place your CO detector here, perform the inspection, you're going to follow your worksheet that you have, and once you complete it, you're going to go back and then look at your CO to ensure that there's no leaks of carbon monoxide around. Now, we're also going to be looking at how does water get into the system itself. Here we have our cold line, so we got our shut-off valve that's coming in here. We're looking at our connections, look fantastic. I don't see any leaks. We're going to be following those connections. I see the valve again. And then we're going to look at our hot water line coming through. Now, there is no defect to have a valve or a missing shut-off valve on the hot water line. It's a nice thing to have, but if there is none, it's not a defect. But again, you're going to be looking at the connections, you're going to be looking for any corrosion or any leaks. And also an indicator is we may not see it here, but sometimes you may see it on the top or possibly on the floor. So you got to be kind of observant when it comes to possible leaks. So after you perform the inspection and you're going through your checklist and you identify the age of the system to your client, one of the most important things is that you want to give your client some confidence that do they need to start purchasing or start saving for a system, or is the system operating and they're going to be good. And that's how you perform a hot water tank inspection with the fuel being natural gas. I'm going to show you about another hot water tank system. This particular system is called an indirect system. And we know it's operating because we turned the faucets on in the bathroom and the kitchen. We felt the hot water. So here we're going to look at the actual component. So when it comes to an indirect system, it is hot water that comes from a boiler and heats up water inside the tank. So when it's being requested at the kitchen or at the bathroom, the water in the tank is going to decrease, therefore asking for cold water to come in. Once that temperature decreases in the overall tank, the boiler is going to kick on and then send hot water to heat up the water inside the tank. Now, what we're going to end up doing is looking at the physical components. So we're going to be looking at the piping that's coming from the boiler system, and again looking at the joints to see if there are any leaks. We're going to look at the pipes coming in and coming out. We can see we have drain lines for the system and we don't see any leaks coming from the drain line. Next, we're going to be looking at the temperature pressure relief valve. We note that we do have a temperature pressure relief valve, and we want to make sure that we have an extension that's coming off and coming all the way down, which we've noted. And then the last item we're going to look at is the actual tank itself, the overall condition of it. And this is a fairly new tank. We're not seeing any rust and things of that nature. So what you're going to do now is you're going to go to your heating system, domestic hot water tank. All right, we're going to identify that this is an indirect system. That's the type of tank. The energy source is going to be the hot water coming from the boiler. The overall capacity of it is going to be determined on the system over here, right on the nameplate, which is a little difficult to see. So we've got 30 gallons here. That's for the tank. We definitely have a temperature pressure relief valve, and we have an extension. So what you're going to end up doing is determine that the system is operating at the kitchen and bathrooms. Then you're going to come in here and look at the individual components of the indirect heating system. And then you're going to go back to your checklist to make sure you're not negligent and check everything off. And that's how you end up performing an indirect hot water tank system.
In this lesson, you will learn the basics of inspecting a hot water heater and the various types of hot water heaters. Typically, in a household, hot water for the kitchen and appliances, bathrooms, washing machines, and others are provided by a domestic hot water heater. A domestic hot water heater is a system that changes the cold supply water into hot water. A typical domestic hot water heater is a water tank heater. This unit is normally located in the basement, relatively close to the chimney of the house. There are several types of domestic water heaters. The most common are instantaneous water heaters, indirect water heating systems, storage tank water heaters, or on-demand, as in tankless water heaters. Hot water is heated in the boiler. A small tank is kept hot in the boiler, and when hot water is called for, the boiler fires up and produces more hot water. This system is no longer being produced and will only be found in older homes. Indirect water heating systems combine the household heating requirement with the household hot water needs. A single boiler is used, requiring only one combustion burner and one vent. These systems employ an insulated external storage tank with a high-efficiency, low-mass boiler to heat the water. Storage tank water heaters are by far the most common type. These systems heat and store water in a tank so that the hot water is available to the home at any time. As hot water is drawn from the top of the tank, cold water enters the bottom of the tank and is heated. It is not uncommon to find hot water heaters using an oil-fired burner. An oil feeder line will run from the oil tank to supply the unit with fuel. The most common tank uses natural gas, and electric units are common when there are no natural gas suppliers in the area. These systems, also known as on-demand, do not have a storage tank. They heat water only when it is needed, thus avoiding standby heat loss through tank walls and water pipes. The most basic units consist of either an electric element or a gas burner surrounded by flowing water. In general, 120 degrees Fahrenheit is the maximum safe hot water temperature that should be delivered from a fixture. Therefore, hot water above 120 degrees Fahrenheit can be considered hazardous. The user should always reference the user manual for their specific product. A hot water tank should be 18 inches off of a garage floor. The fear is a pilot light or a spark from the electric coil could cause an explosion if there has been a gas leak from the automobile. Typical defects of a domestic hot water heater: missing TPRV extension, no drip leg at end of gas supply pipe, or old age. Performing a domestic hot water heater inspection. 1. Verify presence of hot water from tap. And 2. Inspect the unit for condition and safety. Follow the checklist. Take a few minutes to review the next 2 slides and the inspection worksheets for a hot water heater.
This chapter dealt with hot water heaters. There's 4 different styles of hot water heaters. There's a tank, there's indirect, there's on-demand, and there's instantaneous. And the chapter covered all those, how you can identify them and what to look for. But the nice thing about hot water heaters is they're either working or they're not working. I'm going to go inside, I'm going to turn on my hot water at different faucets. I'm going to make sure it's plumbed on the left-hand side, and if it comes out hot, that then tells me that the hot water heater is working. The only other thing I'm really concerned about is in looking at that system, whether it's a tank or whatever, looking at the system, is it in good condition? Is it old, ready to fail? Because I'm going to put on there on the report approximately how old it is. Is it beyond the end of its useful life? I'm going to look for the safety features, and that's it. So other than being able to identify it and make sure that it's working, there's really not much else to do with hot water heaters. Good luck on the quiz.